Okay, welcome back to the fourth lesson for the polynomial unit. We are going to be looking at the common factors today, and not only the common factors for numbers, but also for expressions. And we're going to remove them as to factor out the common factors. Okay, so let's look at the formal questions here first. We have two numbers, 12 and 28. Hopefully, by now, because these two numbers are somewhat small, you can see that the greatest common factor, okay, without doing any work, being a 4. If you can't, recall we can do it by continuous division. I prefer continuous division method because it's a little bit shorter to do. And then you can see it's just 2 times 2, and therefore it's a 4. Okay, so that's how you find the greatest common factor between two numbers. Now, we're going to extend that idea to expressions, okay? So recall, a factor is simply something that you can divide these polynomials or these expressions by, okay? So for example, for the x to the power 4, the factors of x to the power 4 would be x squared, x cubed, and x to the power 4. These are all factors of x to the power 4, because you can actually divide x to the power 4 by any of these, okay? Similarly for x power 6, you can, the factors will be x squared, x cubed, all the way to x to the power 6. And therefore, you know what? I'll actually write out all of them. X to the 5 and x to the 6. And therefore, for GCF, the biggest common factor would be x to the power 4. Okay? Because x to the power 4, you can divide both x to the power 4 and x to the power 6 by x to the power 4. And therefore, that is a factor, and that is, in this case, the biggest. Okay, so what we do is, or based on this example, you can see what we're doing here is essentially, as long as the base is the same, then you're looking at their exponents, and you're taking the smaller one of that. Okay, so you can see, for example C, you can see here, this is x minus 2, that's also x minus 2, so the base is the same here. And therefore, the GCF is going to be x minus 2, and now you compare the exponents, we take the smaller one. Okay, and that is the greatest common factor, okay, of those two expressions. Okay, so that's how you find the common factor and the greatest common factor. We now going to actually factor. Here it actually says to find the greatest common factor of a polynomial, you want to find the greatest common factor of the coefficients and then the greatest common factor for the variables. Okay, so again, here is x to the power 4 and x to the power 6. The greatest common factor of that is x to the 4. Again, because the base is the same, you look for the smaller exponent. Okay, so now we are going to factor. Okay, so the idea of factoring is the opposite of multiplying. Okay, so it's like division almost. Okay, it's not quite division, but you're factoring means you're taking out the common factor in this case. Okay, so it's the opposite of multiplying. For example, now you know what? I'll show you, and then I'll show you the opposite. Okay, the multiplication part. So if we want to factor 5x plus 10, what you do is you look for the common factor. So what goes into both 5x and 10? Well, again, it says to look for the greatest common factor of polynomials, what you do is you look for the common factor of the coefficients, okay, or the constant. So here's the 5 and here's 10. What goes into both 5 and 10 is 5. Now there's x, but there's no x, so there's no common factor for the variable. So the only common factor that we have here is 5. And we're going to factor that out. Okay, now when we factor it out, it means, again, like I said, it's the opposite of expansion, of multiplying. So we're going to divide. We're going to go 5x divided by 5, and hopefully you will know that we end up with just x, plus sign, still plus sign, and then we have 10 divided by 5, and that is a 2. Okay, so this is how you factor. 5x plus 10, if you factor that, you get 5 times, in brackets, x plus 2. Okay, now what I'm going to show you right now is, let's say this is the question, and the question asks you to expand. And if we were to expand this, we would need to distribute. So then that's 5 times x, that's 5x. And then that's 5 times 2, and that's 10. And you can see if you expand this expression, that's exactly what we have there. Okay, so that's what I'm saying. Factoring is the opposite of expanding. It's the inverse. Okay, you're doing the opposite operation. Okay, so that means, the good thing about this is that you can always check by expanding. And if you do get the original expression that you have, that means you factor it correctly. Okay, so I will do one more and then I'll let you try C. So for part B again, we have two terms here. So you look for the common factor. So that's a 3, that's a 6. So the common factor here is a 3 for the coefficient. Now again, there's x squared, but there's no x here at all. There's no variable. So 3 is the common factor. And now, once you figure out the common factor, then you just divide. 3x squared divided by 3 is x squared. 6 or negative 6 divided by 3 is negative 2. And that is your answer. And again, you can always check by expanding it. Okay, so I'll do it for now. Obviously, I'm not going to do it later on. But for now, I'll just check and I'll show you. 3 times x squared is 3x squared. 3 times negative 2 is negative 6. And you can see these two are the same. That means we did it right. Okay, so why don't you try part C and see if you can get it right. So a little bit more complicated because there are 3 terms, but the idea is the same, okay? You look for the common factor for the coefficients, and then the greatest common factor for the variable, okay? So give it a try. Okay, so hopefully you realize that's 12, that's 8, that's 4. The greatest common factor for the coefficients would be a 4. That's x to the 4, x cubed, and x squared. Again, you can see the variable is the same, right? So the base is the same. Now, to look for the common factor, you look for the smallest exponent, which is a 2 here. Okay, so now once you figure out the greatest common factor, now you're going to divide them. Okay, so you divide each term at a time. Okay, one term at a time. Okay, so 12x to the 4 divided by 4x squared. So when you divide them, remember you divide the coefficient with the coefficient. So 12 divided by 4 is a 3. X to the 4 divided by x squared, that's x squared. Remember or recall, when we divide powers with the same base, what we're doing here is we subtract the exponent, right? So 4 minus 2 is a 2. Minus 8 divided by 4 is a 2. That's x cubed divided by x squared. Again, that's x cubed divided by x squared. Same base, you subtract exponents, so 3 minus 2 is a 1. You don't need to write the exponent of 1, but I'm just showing you that, okay? And finally, 4x squared divided by 4x squared. Hopefully that's clear. That's just going to be a 1, okay? And you can, again, always check by expanding it. And if you do that, multiply, you should get 12x to the 4 minus 8x cubed plus 4x squared. And that is exactly the same as what we have here. Okay, that means we did it right. Okay, for part D, a little bit different. So I'll show you this one here. We still have 2 terms, okay? And this one looks a little bit more complicated, but it's still 2 terms. We have the coefficients of 2 and 4, so the greatest common factor between those 2 numbers is a 2. We have 2 powers, okay? So this is x plus 1 as the base to the power of 2, and this is just x plus 1 to the power of 1. So they have the same base, right? Namely x plus 1. And you look for the smaller exponent, which is just 1, okay? So the greatest common factor between these 2 terms would be 2 times x plus 1. Okay, and now once we have our common factor, then we can divide them. Okay, so we have 2 divided by, or 2 divided by 2, which is just 1. So I don't need to write down the 1. We have x plus 1 squared divided by x plus 1, which is just going to be x plus 1. I'll write that in bracket as well. Okay, just in case if it was not a power of 1. Okay, again, this is the same base, and that's why you just subtract the exponents when you divide them. So 2 minus 1 is a 1. Okay, plus 4 divided by 2 is a 2. We have x plus 1 divided by x plus 1, which is just 1, so we don't need to write that down anymore. Or, I mean, you could write down as 2 times 1, but there really is no point. Now we can simplify here inside the brackets a little bit. So I'm just going to copy down the first 2 terms, 2 times x plus 1. Here we have x plus 1 and then plus 2, so in total we have plus 3 here. And this is your final answer. Okay, so that is part D. I will show you one more with part E, because this one, again, looks somewhat complicated. But again, we have two terms here, because we have one minus sign. So this is our first term, and that's our second term. We have coefficients of 6x squared and 10x. Again, number first. You look at 6, look at 10. The common factor there is 2. You have x squared, you have x, same base, so the common factor is x. We have 3x minus 4 to the power 5, 3x minus 4 squared. So the common factor, again, same base, right? So the common factor is going to be 3x minus 4. Now you look for the smaller exponent, which is a 2. Okay, so that's the common factor. And now we can actually divide the terms individually, okay? So we have 6 divided by 2, which is a 3. We have x squared divided by x, and that is x. Again, you subtract exponents, so 2 minus 1 is 1. We have 3x minus 4 to the power 5 divided by 3x minus 4 to the power of 2. So same base, subtract exponents, it's going to be a 3. Minus, this is going to be 10 divided by 2, so that's a 5. X divided by x is 1. 3x minus 4 squared divided by 3x minus 4 squared is, again, 1. And that is your final answer. There's no point of expanding this, because then that's going to make it really, really ugly. So in this case, I would probably rewrite this as 2x in bracket, 3x minus 4 in bracket squared. And then because we have, brackets here, so I'm probably going to write this as a square bracket. You don't have to, but it just looks a little bit nicer with different kind of brackets, okay, to show that these are together and these two brackets go together. Okay, so it's just more clear, that's all. Okay, so you can see it gets a little bit complicated at the end here. Okay, so you'll need to practice a lot. You need to practice a lot to get used to the idea of factoring. Essentially, what you're doing is you're looking for the greatest common factor and you just divide them. Okay. And when I say divide them, it actually means factoring them out. Okay. So, but that's essentially what you're doing. Okay. The next example I'm going to show you is factoring by grouping. Okay. So this is also kind of interesting. It says when a polynomial has 4 terms, it may be possible to factor by grouping. Okay. And how do we do that? It says to factor by grouping, the first step is to group the polynomial into pairs of 2 terms. Okay, so in this case, again, this is, you might need to sometimes mix up the order. Okay, I think the second example is going to be like that. Okay, but the first one, I'll show you, we're just going to group them by the first 2 and the last 2. Okay, so that's the first step. I'm just going to group them by, and I'm going to rewrite it. And I'll rewrite them in separate set of brackets. Okay, and now from here, what I'm going to do is I'm going to factor each pair. Okay, so for the first set of brackets, the common factor there is x squared. And if I factor x squared out, again, remember when we factor x squared out, that means we're going to divide the x cubed and x squared by the x squared. And that would give us the terms inside the brackets. So x cubed divided by x squared is x, plus x squared divided by x squared is 1. Okay, so I'm done there. Now for the second set of brackets, the greatest common factor there is a 3. And you can divide both these terms by 3. So 3x divided by 3 is an x. 3 divided by 3 is a 1. Okay, so that's the second step. The third step is remove the common factor. Now, you can see we have 2 terms, 1 and 2. Now, both terms contain a like term. Okay, you have both terms contain x plus 1. So that is our common factor, right? Again, because both terms has x plus 1, so that is common, and that is our common factor. So what we're going to do is we're going to factor x plus 1 out. That's our common factor. And let's see what we have remaining, okay, after we divide them. So we're going to take the x squared times x plus 1, and we're going to divide that by x plus 1. Now, because we are dividing the x squared times x plus 1 divided by x plus 1, I'll show you that on the side. Because these two binomials are identical, you can simply just reduce them. You can just cancel them out, right? Because they are the same thing. When you divide two of the same things together, it's just a 1. So here you end up with x squared. Plus, if you do the same thing here, 3 times x plus 1. And if you factor out x plus 1, again, it means you divide them. Again, they are completely identical. You can just cross them out. And that is your final answer. Okay, so you end up with x plus 1 times x squared plus 3. Now, in this case, okay, this one, for this example, let me erase this. Let me actually show you by expanding and that they are actually the same. Okay, so if we were asked to expand this, you got to expand like that. So x times x squared is x cubed. X times 3 is 3x. 1 times x squared is x squared. 1 times 3 is a 3. We write this in the descending order for the exponent. You end up with x cubed plus x squared plus 3x plus 3. And you can see this is exactly the same as that. Okay, so we know we did it right. Okay. For part B, this one is actually we don't actually need to rewrite the order. Okay, so this one is not that bad. So why don't you give it a try? These two are the groups. Oh, the minus sign there though. Okay, be careful. Give it a try. Okay, I'll give you. Or you can pause the video and I'll show you in a bit. Okay, so in this case, for the first two terms, you can see this is a squared and this is ab. So both terms contains a. So that's our common factor. A squared divided by a is an a. ab divided by a is a b. Okay, so that's what we have when we factor out the a. This is negative 2a minus 2b. So the common factor here is actually negative 2. Okay, you always, whatever this sign is, you always keep it. Okay, so minus 2. And now you got to be careful. Okay, when you factor out negative 2, so again, that means we're dividing these two terms by that. So it's negative 2a divided by negative 2, and that gives us an a. That's negative 2b divided by negative 2, and that gives us a b. So here is the key, right? You can notice that this time inside the brackets, that's a plus b. Inside the brackets in the first example is both x plus 1. They must be the same. If they are not the same, then there's no point of factoring by grouping. Okay, the reason why is because these two brackets are the same, so we can actually factor that out even more. Okay, we can factor that out. Okay, so if you factor a times a plus b by a plus b, again, these two, right, a plus are both a plus b, so if you divide them, they just cancel out. You end up with a. When you divide negative 2 times a plus b with a plus b, again, the a plus b and a plus b just cancel out, so you end up with just a minus 2. And that is your final answer. Okay, you can always expand to check to see if it's right. Okay, I'll leave that to you. You can do that on your own. But for now, you just need to trust me, okay, that they are the same. Obviously, sometimes I do make mistakes, so it is always good to double check. Okay. Fine, I'll do it. Okay, if you expand this, let me do it quickly here. It doesn't take that long, so I'll do it. A plus b times a minus 2. There you go. A times a is a squared. A times negative 2 is negative 2a. A times b is plus ab. B times negative 2 is negative 2b. Again, you can rewrite this in this order. Then you can see that they are exactly the same thing. Okay. Last example, I believe. Yes. Okay, so here we have a square that is drawn inside a circle with radius 11x. Okay, you can see there's a square, and that's drawn inside a circle, and the radius is 11x. Part A says write an expression for the area of the shaded region. Okay, so part A, we are looking for the shaded region. So that's this piece, right? That's that piece. All these 4 pieces added together. So the idea is to find the shaded area is to take the area of the circle and subtract the area of the square. Okay, that's the idea. Now, how do we do this? Well, so let me write it down. Area of circle minus area of square. Okay. Now, how do we find the area of the circle? If you recall, the area of the circle is simply pi times radius squared. Okay, and the area of the square is going to be the length times the width. Now, and they are the same in this case. However, unfortunately, in this case, we do not know what they are. We could find them out by using Pythagorean theorem, because if I just draw this line right here, this would also be 11x, right? Because that's the radius as well. However, I am not going to do that. Instead, I'm going to use the area of the triangle to find the area of the square in this case. Because if I extend this, I have a triangle right here. Okay, that's a triangle. If this is 11x, then this is also 11x, right? Which makes it 11x plus 11x. The total is going to be 22x. And if you recall, to find the area of the triangle, it is simply base, which is 22x, times height, which is 11x, right? Here's the height, divided by 2. That would be the area of this triangle. Actually, you know what? I'll write it in red. So that would be the area of the triangle. Here we go. 22x times 11x divided by 2. That's this piece right here. Now you can see we have the lower triangle. We also have the upper triangle. And therefore, what I need to do is I need to double it. Okay, and that would be my expression. So now I am going to change the area of the circle because I wrote r squared, but we know r, the radius, is 11x. Okay, so that's my expression. And now I can expand. This is going to be pi times 11 squared is 121. And then x squared is still x squared. Minus, well, you can see clearly that's divided by 2, and then that's times 2, so they just cancel out. We have 22 times 11, which I have no idea what it is. It's 242. Oops, 242. X squared. Okay, x times x gives us the x squared. So that is the, I can rewrite this. Usually we write coefficient first, right? So, or the number first, so 121 pi x squared minus 242 x squared unit squared. And that's the answer for part A. Okay, now for part B, we want to factor this. Okay, so let me rewrite this. 121 pi x squared minus 242 x squared. So if we look for the common factor, here's 121 and that's 242. Hopefully you realize that 242 is simply just twice the 121. So 121 would be our greatest common factor. There's x squared here and there's also x squared there. So that's our common factor, the greatest common factor in fact. And now we just need to divide. Okay, 121 divided by 121 is 1. We have a pi there that's not divided, so we still have the pi. X squared divided by x squared is just 1, so we end up with just pi when we divide 121 pi x squared divided by 121 x squared. Minus 242 divided by 121, that's just a 2. X squared divided by x squared, that's just 1. And there you go. That is our final answer. If you factor that expression, you get 121 x squared times pi minus 2. And that is the expression. Okay, so when you factor polynomial expressions, the very first step that you should be doing is look for the common factor. And when you remove the common factor, you are dividing each term in the original expression by the common factor. Okay, and whatever you're left with, you put that in the brackets, and that would be it. Okay, so I think this factoring is somewhat a new idea. So definitely do lots of practice, and if you need some help, let me know. Okay, good luck.